Oh, hello everyone. Just a quick video to show you how to use the Skyrim behavior tool. Also talk a bit about maybe some of the peculiarities of the engine and how these files kind of interact with it. So we'll just get started by opening up the tool itself. This is my version of the release build with all the DLL files included. And we'll just start the tool up. So up here you'll find you'll have two options. One of them will be to open a packed project, and the other to open an unpacked project. So the thing is, the tool uses HKX internally to convert the the behavior files and project files, etc., between the packed HKX binary format and HKX XML, because my tool can has to parse through the XML. It doesn't know how to interpret the binary, so it uses HKX internally if you select this option. So you would select this if you're selecting files that are unconverted, and then the tool will just call HKX to do what it needs to do to convert to the HKX XML, which is the format that my tool can parse through those files. So if you've already done that, then it's much faster just to open unpack projects. So for now, I'm just going to start by opening pack project because I've got a packed project set up here. Although, first of all, one thing that I'll do before that is, so this is my test folder. So this is where the character folder is, and this folder has to be organized properly. The tool just won't work. So this is how it is in the BSA files. You've got default female, default male. These are the entry points. These are, I call them just the project files. These are the entry point for my tool. So you need to select one of these to open up the entire project. We can actually get rid of the first person and animations folders. Just delete them because HKX seems he will just try to convert everything in there, even though my tool doesn't need the animations folder. It does need the behaviors folder with all the behaviors files, the characters files as well, which contain the character properties, and also the animation list, which is important, and the character assets, because the skeleton contains all the information about the bone and how they map to different indices, which is needed by some of the UI elements in my tool. So now that we've got this folder kind of set up, these are all HKX binaries. See, they're all in pack binaries. So we'll go back to the tool, open pack project, let's go back to the desktop. Double click on this. It'll take a moment now because HKX is opened up and it's converted everything. So this is the project UI, what I call. So here you'll have the character properties. So there's a whole list of them there. You can click here to edit them. There's a bit of lag there for some reason. So you can change the name, set the value. This is a boolean value. So the type will be real. So going to attack block, there's the value spin box of the value. HKX CMD doesn't really deal with the floating point values. It doesn't initialize them properly for some reason. Some bug in the tool. That's why you're getting these kind of crazy values for default values. So there's not really much you can do about that. If you want to initialize floats in a behavior file, behavior variables that are floats, you will need to use a evaluate expressing modifier. But I'll probably cover that in detail later, how the specific modifiers work. Just something for you to note. So here we have the bone lists. I had local frame names because initially the plan was to allow the tool to add local frames to the skeleton file. It doesn't do that at the moment because I haven't added support for all the other skeleton classes and there'd be data lost if it did try to create anything. So for now, this is just for reference to look at the rig skeleton, not the ragdoll, just the rig one, all the names of the character. Down here, you've got checkboxes for enabling foot inverse kinematics and hand inverse kinematics if you would like to. So you have all these widgets, you can change the values of these. All this information is actually stored in the character file. And then we have the animations list, and you can add animations list. Now, all this does is it doesn't create a new animation. It just it creates a new animation name in the character file, which you will then be able to reference in your behavior file. Because the behavior file will give you a kind of table of animations that you can select from animations that exist in the character file. It's just the best way to do it, because otherwise you might write in new animation names into behavior file directly, and those animations won't exist in the character file, and then you'll just get T-pose. T-pose is in game. So over here is your list of behavior files in the project, and this is where you open the individual behavior files now. So I'll just crack open block behavior by double clicking, and here's the behavior graph view. So I'm just going to zoom out. Use the mouse wheels to scroll in and out, and you can click drag to move things around as well, move around the scene. So lots of if you go up to view, you can expand all and collapse all. So this can be kind of useful if you want to just kind of go through the branches bit by bit if it looks too messy for you there. And just clicking on the icon will turn green, and you'll be given the object data view here. So this is the behavior graph. Class name is noted here, and this doesn't have much data to it, this particular class. So we've got a spin box to change the variable mode, which is an enumeration type. The name of it, you can change the name of it. We want to do that here. And then double clicking this will pull up the table of generators. So this is a list of all the other existing generators in the behavior, and you can reroute these pointers to wherever, and the graph will update. But we don't want to do that here for now, so we're just going to cancel that. And block behavior, this is the root state machine in block behavior. So as you can see, you've got a name, event send, and state of transition changes, a load of other variables like start state ID, which it's not actually in int32. Well, it's not displayed as an int32. My tool will figure out which states are available to change. So you don't set this by setting an integer value. You just choose from the drop-down list, because this behavior only has two states. As you can see down here, block root, block sprint. One of them maps to eventually to selector generation, another to sprint behavior reference. So it's kind of handy that it just gives you those two options, because that's all the only options that there actually are. So we're just going to leave that at block root. And these are just the event IDs, returns or previous stage event IDs, random transition event IDs. So if you want to select an event, you double click here, and it'll give you a table of events that you can select from. So there's just a list of some of the events there. We're not going to choose any of them. Now this is, as you see, you've got the data widgets. The object data widgets are arranged into rows. So the name of the actual data field or parameter, whatever you want to call it, is here. The second one is the type. The third is bound variables. So what you can do for a lot of these objects is you can bind behavior or animation variables, whatever you want to call them, and then change the values of these data fields at runtime by changing the values of the behavior variables. So in order to select which behavior variable you want to choose, you see some of these are not applicable. You can't bind the variables to these. Now you could to actually do this to events, but I haven't allowed that. It's kind of hackish and dangerous, because these events are actually really just integers, which are indices into the list of elements, array elements. It's an array of elements, really, of events. I mean, so for now we'll just show you there's three fields that we can bind properties to, and if you double click in there, you'll get the list of the behavior variables in this particular behavior file you can bind. So the tool will prevent you from binding incorrect types. So this is sync variable index we're trying to bind. It's in int32. So if you try to bind a boolean, select it, it'll give you an error message saying invalid data type revealed. But otherwise, you can just find int32 that will just do async return state here. So when we select it, you'll see that it's now the name of the bound variable is noted here. So that's how you would bind variables. Now you can also bind character properties. And character properties are basically think of them as global variables for the particular project. They're kept in the character file, as I said, along with the animation list. So if you tick this box and then double click, now you have a list from the character properties. So select the character property, and now if you select something from here, it's a character property that's actually bound to your data field. So we're not going to do that for now. Actually, just going to set this back to none. Anyway, this is for state machines. The state machines have a dynamic number of children. They're one of the few classes that you can have. You can add as many states as you want. So in this UI, you can double click add state with your generator. It will give you a new state that's linked to a new generator of the type that you select from here in this list. So you can see flip generators, pose matching generators, etc. Other generators. You can also remove selected states here. If you double click to remove it, you can show you remove the state to there, and you can also edit it. Here you can also see the transitions list. There's no transitions defined, wildcard transitions. There's none for this particular state machine. So we'll just take a look at the state UI. So again, it's kind of similar sort of user interface, type, variables, values. And you can change all this whichever way you want. Visual glitch there. To sort out. In here, there are also transitions defined here. So you can see the transition names are kind of generated, kind of automatic. You might get some odd transition names, but they usually give you a good idea of what's going to go on. So this is going to block sprint. So this is obviously a transition from block root state, which is the one that maps to here, to the manual selector generator, to the sprint behavior reference state. See, states aren't represented in the graph. Just only their children. So that's why there's the state machine here, but the individual states themselves aren't represented in the graphs. I think it just clutters the graph too much. It's unnecessary, in my opinion. So we'll just start expanding some of this to follow how it's going, how things are going, how the program flows really. So a block behavior is kind of the entry state machine. You can see the start stage event ID is block root. This means it's going to map through block root initially. And block root itself, as you can see here, maps to block right hand type and select generation, which is here. Of course, and you've got your transition defined here, which we can take a look at here. Double click to edit, and this is your transition state machine transition info array. So for this particular transition, we have no trigger interval events set. The blending transition effect that you can enable, toggle through this button. So this checkbox will basically allow you to toggle the transition effect if you want. Otherwise, every time it's going to generate a new blending transition effect, which isn't exactly optimal, but it's just the way I've done things here. So we can turn that off to destroy the transition effect and null that particular data fields. These transition effects aren't actually necessary, but usually you will want to use a blending transition effect for transitions between states. It makes transitions between animations much smoother. So we can click on this if we want to actually edit the existing transition effects. So transition effect here, you've got event mode, duration. As you said, you can map variables or bind variables to these two fields, and a few other enumerator types, but I'm not really here to talk about the specific types and how they work, really, just to show you kind of an overview of how the tool works. So up here is the button just to return back to the state, and we can return back to, return to the transition, return to the state, return back to the state machine. So it's a bit nested there, but anyway, we'll go to the manual selector generator. Again, similar sort of UI generators. Double click in here with the child from the drop down list, remove the generators or edit them. In this case, editing just means selecting a new generator from the generator table. So as you can see down here, we can staff right block blend this state, or this particular selector generator indices index maps to that particular. It's a Blender generator. You can see from the information there, the type, name, and type. We're not going to change anything there. So if you click on the icon here, you can see it's plus indicates that click on this, it has children. It's going to expand one level of the branch. So expanded one level of the branch, there are three different children to this. The reason why it's not more than that is because, as you can see here, we've got block root, modifier generators, then just staff, right block bench, block back to block root, and crossbow. So the tool doesn't create duplicate icons in the same kind of branch because it's just unnecessary. So it's done that to kind of conserve space. But as you can see, there are three different types, or three different branches, really. The others are duplicates. So it's unnecessary to do anything else. Now, one trick that I've added just to the manual selector generator and also the modifier list, when I do this here, you can actually swap the kind of indices around, I would say. So, for example, I can click and drag staff, right, block, bench, and I can swap it with any of these. This will internally rearrange the data, and the graph will update the view depending on how you switch things. So, if I just swap this with here, the data is swapped, but the icon you can see, staff, right, block, bench, isn't, because it's still the kind of fourth or fifth reference, much more than seventh or eighth. But if I click, drag, and pull it up to the top and swap it now, you'll see it repositions itself accordingly. So that's the way that is kind of organized. So I'm going to pull that back. So you can follow any particular branch here. As you can see, the right-hand type variable is the one that's bound to control the selected generator index. So that really decides where this block behavior is going to go. So most of them go to the block root modifier generator. So let's say one-handed sword, dagger, anything like that. Also, the two-handed weapons are all going to be mapped through to this. As I said, it's only the staff and the crossbow that are going anywhere else. So we'll click on this as a modifier generator. It's very simple. It's got a link to a modifier, which is the modifier list. As we expand this, you can see the modifier list here, and the block manual selection generator, which is referenced here. So the modifier list, again, kind of similar to manual selector generator list. We can rearrange this by clicking and dragging if we need to, because the order of the modifier lists, the modifiers are applied in the order in which they set up in the modifier list. So in case the order is important, you want one modifier to execute before another. So that's the way that's organized. And as I said, it's the same deal with the generators, except add modifier and then a much bigger list, because there are many more modifiers compared to generators. One thing we'll notice is that some of these modifiers, particularly some of Bethesda's modifiers, just don't function at all. Some of Havoc's ones don't either, like the move character modifier, which sounds very promising. From my experiments, it doesn't work. But there are a good few modifiers that do work. Can be kind of useful and interesting. There's a couple of interesting ones here, like the there's a the decompose vector modifier, which can split up vector variables into floating point variables, which can be kind of useful, especially if you want to split up a target location variable, which is a vector 4 variable that's set by the game engine used in head tracking. You can get some interesting kind of values out of that might be needed for certain particular purposes. There's also the limb inverse kinematics modifier, which does work as well, which is used to prevent collisions, modify certain bones, the animation that are colliding with certain surfaces, say collision layers. Now, unfortunately, you cannot set the collision layers in this modifier, it just works only for a character's skeleton bones that collide with the terrain. But it's still kind of useful. So just to know that I've added support for some modifiers that don't actually work in game. So just because you can put it in via this tool doesn't guarantee that it will actually work. I just found out after I added support for the class that certain ones just don't work or are useless. And anyway, we can crack open the modifier list, and as you can see, it's block start, block stop, event-driven modifiers are here, and they themselves will just have a modifier associated with event-driven modifiers. Um, like they have events that trigger their own child modifier. So, and this is just an evaluate expression modifier. So you can see there's a list of expressions that go in if you like. But anyway, that's the classes. I don't really want to talk too much about them. So back to the lock minus selector generator. There's first person and third person. This is a switch. As you can see, the I first person variable determines the path this is going to go on. This is, I don't know why Bethesda did this. I think this is kind of leftovers because they ended up splitting up their behavior files between first person behavior files and animations and third person. So this is just some remnants of the decision they made long ago. So we're not really interested in the first person path, but it's the third person block bone switch. While I'm at it, one thing you might notice there are different colors for icons. So I kind of color coded them just to give a kind of better indication from far off of what the branch is actually doing. So this one, reds or white or dark reds, all icons that are colored like this are a kind of blender generator. So bone switch generator, this is just a Bethesda convenience class that is essentially a blender generator, blends animations together. So it's red, whereas just typical modifiers will typically generators will just be gray. Generators that don't do anything particularly special. The only exception being actual state machines, which I've colored blue. And behavior reference generators I've got here just colored kind of gold, dark yellow. Modifiers are all pink, purple, and I believe I think it's yellow for clip generators. So I actually haven't been looking at this stuff in a bit. So we'll crack open the third person bone switch generator data, and you've got blocking behavior, blocking lower body behavior. So we'll follow this one a bit, and so this is the blocking lower body behavior. There's two states: block standing state or locomotion state. So there are no wildcard transitions here, so transitions must be in the state itself. And as you see here, in the block standing state, there's a transition to shield locomotion. And the event itself is move state. Nothing surprising there. The state ID is shield locomotion. As you can see from the drop down list, it will give you the only other possible state IDs. So every time you load this widget, it will figure out what are all the other possible states and just give you this instead of just you having to set an integer, which would be messy and lead to all kinds of errors. There's a couple of things grayed out here that I just haven't allowed, or you need to tick a flag to nested state ID transitions that go through a state machine, go to a nested state. You need to take one of the transition flags here, so use nested state, and then this two nested state will become usable. Anyway, we'll return. So this one will be block standing root, goes to shield turn modifier generator. Open that up. Turn modifier list, block standing state blend. And this is the blend generation UI, so you've got all your flags, so floating parameters like blend parameter, etc. You can click on the child, child. As you can see, the bound variables. This is actually a property. It's a bone weight array property, it's a character property, pointer to a bone weight array that is defined in the actual character file. And that's why this is loaded up as property already in body, so that tells you that this bound variable is a character property, not a local property, a local variable. And this is a bone rate way, so we're actually given the option to edit it, but there's not really much point. You probably won't load up anything since it's really getting the information from the character file. This is just a bone rate way UI. It's not really good at the moment, but it does the job. You just select the individual items and select the bone rate, and you can change the value of it. You can see right first, set point 2. So you can just return, and you can just basically keep following the branch down. So you're following the flow of this behavior. Although one thing to know is obviously we've gone through this bone switch generator. So these branches are being blended. So this is the lower body animations that are being blended, and the upper body is actually, as you can see here, blocking behavior. So one thing that I might note is when an object is referenced more than once in the behavior, it will have multiple icons. But this is the first reference of blocking behavior in the file. So it has all its children set up and etc. So this as you can see here, we've got it referenced again. There's a little arrow. So this has no children, no child icons. When you click this, it'll pull you up to the first icon representing the first reference of blocking behavior. So you can click on it normally and just have a look at its data. It's going to load its data. If we want to go and have a look at its children as well beyond in the graph view, just click here and pull focus on the actual first instance of it. So as you can see again, 3 states. So no surprise that we've got 3 children here. And well, one is block state behavior, block hit. So obviously this is for just idle block behavior. This is obviously block hit animations are mapped here, and block bash intro behavior. And the standard state blend is blending this with the shield idle behavior. So just going to take a look. So just upper body is blended with the rest. So anyway, we can keep opening up these branches individually to follow the flow, just to help us understand how the behavior file is going through, and eventually you'll reach a point where you actually start to hit the end point of any branch, which is usually going to be a clip generator or synchronized clip generator or behavior reference generator. They're typically the end points of any branch. So, for example, we're hitting them now. So yellow is, and you've got certain shapes, some basic shapes. So circle is another kind of endpoint. Yellow is clip. It's a clip generator, so we can clicking it here, and you have your list all the different parameters that you can change. The animations is here, so the animation name. When we double click this, it's actually going to bring up the list of animations that you've seen previously, just over here. So this list is just going to be brought up to you, because we don't really want you selecting or pumping in or writing in the name of any animation yourself, because then you're just asking for mistakes and glitches, because all these reference animation names need to be in the character file animation name list. So if you want to add a new animation, or you want to change this to a new one, you've got to go back to the character data, add the new animation, name it there, and then go back in to this view, and you'll be able to double click on it, and you'll have your animations list, and just select from this list. So anyway, that's kind of the basics of the way graph view works. Now, in terms of editing things. What you've already seen, we can edit using the data widgets themselves. We can also edit by right-clicking. So when right-clicking on an icon, it'll give you a list of options. So as you can see here, we can append generator, append blends, wrap inside generator, wrap inside blend, or just remove the selected objects in this children. So appending generator is simple. You've got a list with options for all the generators that you can append. Now, to something like a manual selector generator, appending something is it doesn't sort of change too much. Like just easily do it. Append, let's say, append a new behavior reference generator. See, it's been let's just give me a warning for invalid behavior name. So this is an example. Behavior reference generator 3 has been created. And here's a list of all the reference behaviors. So we can select any of these, change English, select any of these. So this is a new icon. Likewise, click remove the selected object and it's gone. It's gone. So it's append generator, reference generator. Click on it, it's right. It's right here, right at the bottom. Swap it. Let's change places and then click on it and remove it. Back to the same sort of structure. So that's the way you append it. Now it figures out, the tool will figure out what you can and cannot append. So it's kind of type safe. So this is a clip generator. I can't append anything to it because it doesn't have any child objects. It doesn't have any child modifiers or generators. So you're not given the opportunity to do that. But we are given the option to wrap inside a generator or blend. Blender generators are kind of all the same. You can still, I've separated them just because it's useful. It's the way Blender generators work by blending two branches or multiple branches together. I decided to put them separately to standard generators. So we can wrap inside a generator. What this will do is, let's say I wrap inside a modifier generator. What this will do is it'll create a new modifier generator. This new modifier generator will become the parent of this object at the moment, which is the torch block idle. And this new object would then become the child of the block idle manual selector generator here. So it basically inserts or injects it into this sort of position. So as you can see, it pops in there. Now it fits in its child torch block idle. And as you can see, when we click on the block idle, the torch block idle has been replaced with the modifier generator 17, which we can rename to whatever we want. So test. So the name will update. It's another bug that I need to fix, but it hasn't done anything. It hasn't changed anything much. So you can see we've renamed it, so its name is updated in the graph. So that's how you can, and then we can remove the selected object children. Although, let's say if you want to undo this, you want to, kind of reconnect back to the torch block idle, you want to get rid of this modifier generator, this test one. The way to do it is to actually go to modifier generator test, double click edit. We're going to find torch block idle. To find match the string. So I'm just going to pull this away. So we just find so here it is. Now it's deleted the manual selection generator. We've got torch block idle back again. And we're back where we started. So that's how to edit, how you can inject new objects in, move them, append new objects. So that's just some of the editing features. And as I said, we'll figure out it's fairly type safe, so it won't allow you to connect incorrect types to one another via that menu, this right-click menu. So that's kind of the basic features. As I say, we want to expand everything, expand it all again, to have a look at the whole view. This is how it looks. So what we want now is looking through the list. Let's say we want to save the file. Now, saving the file, it's just going to write it to hgex XML. That's all that will do. So every time you save it, it's just going to write everything to hgex XML. So you can just do that. Just give it a quick list, and it's done. Now we can go ahead and have a look at what this looks like. Because it'll look a little different to the standard one, because the way my tool writes it doesn't write any comments. That's the first thing you'll notice about it. The numbering scheme is a bit different, standard, root level container, and everything's ordered kind of inverted differently to the way HKX CMD does. Now this isn't an issue, because HKX CMD can read this in, it doesn't get spit out any errors, so it can actually handle all this. So this is, but if you want to make sure that the changes that you made are correct, because it is early days with this tool, you can always just take a look at the file itself and find whatever it is you edited. So, as I said, just quick check. This is everything seems to be in order here. As I said, you just check the data yourself. If you're unsure, if you do something in my tool and it doesn't appear to work in the game, always just check the HKX XML. I'm pretty sure most of it is working. Right routines, right to file does seem to work from all my testing anyway. But just something else, if you're unsure, if you don't trust what my tool has done, you can double check it in there. So we go back to it again, and now I've got some useful sort of convenience functions up there. But first of all, I'm just going to go into my Skyrim folder. Data, message, actors. This is a site. Just install the Bruma expansion. Just test it out. As you can see here, there's no character files here. So what you can do is I've added a function where you can export the whole project to the Skyrim directory, or just export the current file. This is useful for testing new behaviors, just export the current file. But if you've added new animations to the project, then you're going to want to export the whole project and not just the current file, because then you'll just get T-balls, because any new reference animations won't be found by the game engine, and nothing will play right. So for this, I'll just give an example. I haven't added a new animation, so I can export the current files to Skyrim directory. So just click that there. The debug log will give you a couple of messages saying export the current file, how long it took, 277 milliseconds, and if you go back, you'll notice character folder in here, behaviors, block behavior. It's here and it's packed into the HKX binary. So it's a nice convenience function that speeds things up when you test your behaviors in game. And so that's basically how you're going to be working flow. So as I said, you go back and rack up other behavior, dash behavior, some master behavior. Do all your sort of work here, and then export individual files to the project. And you can save the project, which just writes all the files in the project to HKX XML. Generally, you won't really do much, because the tool doesn't really need to edit most of the other files. You generally just be editing the behavior file. It's only when you add new animations or add foot or hand inverse kinematics that the character behavior file is then edited, and then you'll want to save the whole project and then export the whole project to make sure that you export the character file as well, to make sure things work as expected. One other thing I suppose I didn't note was just down here for each individual behavior file, you've got your events table, and you can add events, remove, change set flags, point, change the name of the events. And the same with the behavior variables list is here, just like the character behavior, the character properties. Just edit the values. That's all. And as I said, you can remove select variable. Just select a variable. Click this button. Remove it. So just variable down. It will update. It'll update the other kind of objects that reference that variable. So it's the basic functions of the tool. There's a lot more to how these files work and how they interact with the engine. But I just wanted to cover basically how these files look, how to use the basics of using the tool. I still have a lot of documentation to write, and, and make some explanations for how certain classes work, and, and then just other sort of various kind of testing methodologies that are the quickest and best ways to make changes to the files and test. But I'll cover that in another video. So thanks for watching. I hope you find this tool useful.